All right, welcome back. We are going to discuss example 3, but before we do that, we have to talk about some more vocabulary. So let's look at dimensional analysis. That is a big word. Dimensional analysis. So what that is a process that uses rates to convert measurements from one unit to another. That is the process of dimensional analysis, which is what we're going to do. So what I'd like to do is I'd like to start that process, and then after we do it, then you'll understand what dimensional analysis is, okay? To do dimensional analysis, you have to use conversion factors. So conversion factors, what those are is those are basically two things that are equal to each other. But the proper definition is a rate such as 12 inches to 1 foot. So 12 inches and 1 foot, they're the same thing, right? So it is a rate such as 12 inches to 1 foot in which the two quantities are equal but use different units. Okay, so this is a conversion factor. Okay, you're going to have to know this one, and then there's a whole lot of other ones that you're going to have to know as well. So to convert from one set of units to another, you use conversion factors. So we're actually going to be using this a lot. So let's go ahead and practice dimensional analysis with the first problem here. It says a large adult male human has about 12 pints of blood. Use dimensional analysis to convert this quantity to gallons. So we have pints, and we need to convert it to gallons. That is what dimensional analysis is. It's like you start with one thing, and then you have to use conversion factors to convert it to gallons. And so at the end of the day, you have 12 pints equaling however many gallons that is, okay? So there's a few things that we need to know just about liquids. So there are, we could say that there are 2 cups is equal to 1 pint. We can say that 2 pints is the same thing as 1 quart. And we can say that there are 4 quarts in 2 pints. 4 quarts in 1 gallon. Okay, so these are facts. This is what we're going to use in order to solve this problem. Okay, so where are we starting? We're starting with 12 pints. Now, we're going to do dimensional analysis. So what we're going to do is we're going to multiply by a conversion factor. And so what we have to do, we have to go from pints to quarts and then from quarts to gallons. Okay, so that's what we're going to do. So whenever we're doing that, we have to do a conversion factor that has pints and quarts in it. So we know that 2 pints is equal to 1 quart, right? So you can either do it like this, where it's 2 pints over 1 quart, or you can have it like this, 1 quart over 2 pints. It doesn't matter. They're both equivalent to each other. So which one's on top, which one's on the bottom. You can do it either way. Now, how you know which one you use is that, remember that we're basically going to be like multiplying like fractions. So this is like 12 over 1. And remember, whenever you multiply fractions, right, the first thing we talk about is you cross cancel, right? And then we multiply across. Cross cancel, multiply across, cross cancel, multiply across. Well, because whenever we're multiplying fractions, the first thing we do is cross cancel. What we want to do is we want to cancel out that pints and we want it to become quarts. So we write it across. So pints goes across. So if it's on the top here, it's going to go on the bottom there. And then we're going to put the quart information on top. And what do we know? We know that 2 pints is the same thing as 1 quart. Okay? So now we can go ahead and multiply this fraction. Well, what do we have with the numbers? We can't cancel out the 1 and the 1, right? But we can cancel out this 12 and the 2, right? What common factor do they have? They have a common factor of 2. 2 goes into 2 one time, 2 goes into 12 6 times. But we can also cancel out the units. We have pints here and we have pints there. So those cancel out. Then we just multiply across, and what we end up with is 6 times 1, which is 6 quarts, to just 1. Just 1 times 1 is just 1. Okay, so now we have in quarts, but we need it in gallons, right? So now we have to use the, keep going with the dimensional analysis to change it to gallons. So we're gonna go here, we're gonna go here. We have to get rid of quarts, so we know that we're multiplying fractions, so we're gonna put that on the bottom. So we're gonna put it across so we can cancel it out. And then, is there a relationship between quarts and gallons? Yes, there is. We put gallons on top. Then we write in that relationship. There's 4 quarts is equal to 1 gallon. Those two things are the same. That is our conversion factor. Now, since we have that, we just go ahead and multiply these fractions together. We're going to look at the numbers first. 6 times 4, what goes into both of those? 2. 2 goes into 4 2 times. 2 goes into 6 3 times. And then we can cancel out these units. And then we multiply across and we get 3 gallons. And then 1 times 2, 3 over 2. 3 over 2 gallons. So use dimensional analysis to convert this quantity to gallons. So 3 over 2 gallons, or that's the same thing as, so we can say 3 over 2 gallons, or we could change it, since it's kind of like talking about something real, we would probably put it into a mixed number. 2 goes into 3 one time with 1 left over, so 1.5 gallons, which is the same thing as 1.5, or 1.5 gallons. So that is dimensional analysis. So let's go ahead and read this this definition again. It says a process that uses rates to convert measurements from one unit to another. So a process that uses rates, right? So we used rates here, which were our conversion factors to convert from pints all the way to gallons. That's what dimensional analysis is, using a number of conversion factors. Now, what I can tell you is that my son, what is he doing? He's up at the college and he's taking this intro to engineering class. And I was blown away by the amount of dimensional analysis they have them do. I mean, he's doing dimensional analysis all over the place. And it's almost like they're just testing to see if they can do this. You really need to have this skill. This is a good skill, whether you're taking engineering classes, or if you're just trying to convert from one unit to the other, whether you're doing baking or really anything can deal with these different types of conversions. So let's go ahead and do the next problem here. It says the dwarf seahorse Hippocampus zoster swims at a rate of 52.68 feet per hour. Use dimensional analysis to convert this speed to inches per minute. Okay. So what do we have? We are starting with 52.68, and this is in feet per hour. And we need to convert it to inches per minute. Well, the question is do we have it in inches and do we have it in minutes? And no, and no, and no. So we have to actually convert both of these. So let's start with the feet to inches first. So if you see here at this first example, I kind of converted it to quarts, and then I did the math, and then I converted it to gallons, and I kind of just did one thing at a time. However, with this one, I think I'm just going to do it all at the same time, okay? So there's kind of two different approaches. It's the same approach. This is like one step at a time, but since there's so many conversions going on here, I'm just gonna do them all at the same time. So, the first thing I'm going to do is I'm gonna get rid of this feet. So what I wanna know is there a relationship between feet and inches? Yes, there is. There are 12 inches in 1 foot. So that's a relationship. So I can directly get to inches pretty quickly. So I'm going to write this. Remember, we're cross-canceling, so the feet has to go diagonally across. And then we're going to have inches on top. And then we put in what we know. There's 12 inches in 1 foot. Okay? On this one, I'm just going to leave the numbers, but what I am going to do, I'm going to cancel out the units. So these feet are going to cancel out. I'm going to do the numbers at the end. Okay, so now I have my units are in inches per hour. Do you see that? Inches per hour. So inches is good. Okay, we got inches. Now we need to get the hour into minutes. So the question is do we know a relationship between hours and minutes? Well, yeah, we do. We know that there's 60 minutes in 1 hour, right? So we're going to use that conversion factor. So remember, right now, is the hour on the bottom of the fraction or the top? And it's on the bottom, so it means we have to put it on the top, right? And then we put the minutes. So this is our conversion factor. These are the two things that are the same, right? 1 hour is the same thing as 60 minutes. They are the same thing, which means it's really like multiplying something by 1. Just like 4 over 4, right? 4 over 4, it's the same thing over the same thing equals 1. That's the same thing here, like 1 hour over 60 minutes. This is the same, this is the same, they're the same thing, it's equal to 1. You can multiply anything by 1 and you're still getting that same thing. So that's really what we're doing. This is 1, that is 1. We're basically taking 52.68 feet per hour, we're multiplying it by 1, and then we're multiplying it by 1 again. Okay? We're just changing the units. So 1 hour and 60 minutes. All right, cool. So then we need to cancel out these hours. Okay, the hours are now gone. And then we have inches per minute, which is perfect. So really what we have going on is we have 1, 2, 3 fractions that are all multiplied by each other. So we got rid of the inches, we got rid of the units, and the units are now exactly what we need because we need inches per minute. And these are inches, and these are the minutes. So boom, that's what we need. Now what I'm gonna do is I'm just going to do a little bit of simplifying before we just multiply this all across. And we're gonna look to cross cancel. So this 52.68, can't really cancel out a whole lot of stuff with that. But what about the 12 and the 60? Is there a common factor with those two? And I would say yes, 12 goes into 12. The common factor would be 12. 12 goes into 12 1 time, and 12 goes into 60 5 times. So then when we multiply all of this across, what we end up with is 52.68 over 5, and this is in inches, right? Because inches is the only unit left on top per 5 minutes. Okay? And this is, per minute. So I think we need to have this, is this need to be 1 minute? I think it might need to be 1 minute. Yeah, I think it might need to be 1. So does anybody remember how, if we needed to make this a unit rate, how we would do that? Yeah, we would need to just divide that by 5. So I'm just checking right here. So how about you guys go ahead and do that on your own right now. Go 52 point, oh man. Let's make it over here. So 52.68 divided by 5. So go ahead and figure out what that is. All right, so we know that 5 goes into 5 one time. 1 times 5 is 5. We subtract. That's 0. We got to drop this down. It's going to go 5 times 5 times 5 is 25. That's 1. Drop down the 8. 5 goes into 18. How many times? 3 times. 3 times 5 is 15. 3. Then we drop down zeros, and we get 5 goes into 36 times. Right? So how would we write our answer? Is that what you got? Okay, let's see here. Hold on. Did you get, so this would equal 10.536 inches per minute. Okay. I'm just trying to check something really quick. Oh, nice. That's not nice at all. Okay. So there we go. That would be our answer right there. Let me check the book really quickly. Hold on. 1 point. I'm just trying to see if we can leave our answer like this or if we have to write it like this. I don't quite remember that. Dimensional analysis. Yes. Yes. We have to have it in a unit rate. Okay. So it has to be in a unit rate. So we have to make that 1 minute. Okay. So there you go. We are right on that. Okay, let's look at C. Thank you for being patient with me. It says a cyclist travels 56 miles in 4 hours. Use dimensional analysis to convert the cyclist speed to feet per second. Okay, we need it to go to feet per second. All right. So let's go ahead and write down what we have. We have 56 miles in 4 hours. Okay. And this is not in feet, and that's not in seconds. All right. The one thing you're going to have to know before we start this is that you're going to need to know that there are 5,280 feet in 1 mile. And you're going to need to memorize that. Memorize that, okay? So that's going to be super important. Like when we have the tests and things, you could have a test question about this, and you're going to have to memorize it. So 5,280 feet in 1 mile. Okay, so the first thing we want to do, let's go ahead and get rid of the miles. We're not equaling. It's going to be a multiplication, right? And we want to know, is there a relationship between miles and feet? And yes, there is. There's 5,280 feet in 1 mile. So we're going to put the miles across so they cancel each other out. And then we put the feet up here, and then we just write in the relationship. So 5,280 feet in 1 mile. All right. And then what happens? Those miles are now gone. And now we have it in feet, which is great. That is wonderful. But now we need it in seconds. Okay. So do we know a relationship between hours and seconds? I don't, but I know from hours to minutes and minutes to seconds. So I'm going to do that. So hours, that needs to go, make a fraction, right? I'm using that conversion factor. The hours, it's going to go diagonal so it can cancel out. And to minutes, and what do we know about hours and minutes? Well, there's 1 hour, there's 60 minutes in 1 hour, right? So that means that those hours are going to cancel out, but we need it in seconds. So do we know a relationship between minutes and seconds? Yes, we do. So the minutes are going to diagonally go up here, and the seconds are going to go down here. And we know that there are 60 seconds in 1 minute. Then these minutes are going to cancel out. So we're just left with all of this, but we do have our feet per second, which is exactly what we need. So now we have 1, 2, 3, 4 fractions. That's a lot of fractions. And they're all being multiplied by each other. So there's actually a lot of cross-canceling that can happen here. I think what I'm gonna do is start with, so I'm gonna try to cancel some of this stuff out just to make it a little simpler. What can I cancel out? Well, I can simplify this 56 over 4 because I'm pretty sure, does 4 go into 56? Does it go in there evenly? I think it actually does. Let's see here. I'm gonna go to the side here. So 56 over 4. 4 goes into 5 one time. 1 times 4, we carry that down, drop the 6. 4 goes into 16 4 times. 4 times 4 is 16, no remainder. So it goes in 14 times. So 4 goes into 4 one time. 4 goes into 56 14 times. So that makes that simpler. Also, whenever you have a 0 here and a 0 here, that means that 10 goes into both of those. So you can just kind of cancel off this 0 here and cancel off that 0. Okay, so that makes that a little simpler. Then what can I do? Well, I could see if 6 goes into 528. Let's see here. 6, does it go into 528? So that would mean if it's divisible by 6, it would have to be divisible by 2 and 3. Well, it's even, so we know it's divisible by 2. If we want to figure out if it's divisible by 3, then we would just have to add up all these numbers. So 5 plus 2 is 7, 7 plus 8 is 15. 15 is divisible by 3, that means it's divisible by 6. Okay, perfect. So I'm just going to go over here. I'm going to go 528 divided by 6. So since it's divisible by 2 and 3, because 6 is 2 times 3, right? 2 times 3 is 6. So if a number is divisible by 2 and it's divisible by 3, that means it's divisible by 6. So I'm just going to figure out how many times it goes in there. So if 6 doesn't go into 5, but it goes into 52, how many times? 7, 8. Goes in 8. 6 times 8 is 48. Okay? And then we need to borrow, making that a 4. That's going to be a 4. And then we drop down the 8. And then, yeah, 6 times 8 is 48. So, yeah, 8 times 48, no remainder. Well, that's nice. Okay, so 6 goes into 6 one time. And 6 goes into 528 88 times. That's really nice. Okay. So let's see if we can make this a little bit simpler. We have 1, 1, 1, and now we have this 60 over here. So let's see here. I know that I think 4 goes into both of these numbers. 4 goes into 60 15 times. And then 4 goes into 88. I think 22 times. Yeah, and I think that's pretty much it. I mean, because the only thing that goes into 15 is 3 and 5, and 5 doesn't go into either of those, and neither does 3. So that's about all the cross-canceling that can happen. So we are just going to multiply across on top. So we need to multiply 14 by 22. Okay, and that's going to be 8, 2, and then 2 times 4 is 8, and then 2 times 1 is 2, and that's 8, that's 10, that's 3, so 308. So when we multiply across, we get 308 feet per 15 seconds. And remember, we need that unit rate, so we actually have to make this a 1. So that means we're going to have to divide this, 308 divided by 15, because, you know, you're going to divide this by 15. 15 divided by 15 is 1. You have to divide that by 15. So 308 divided by 15. 15 doesn't go into 3, but it goes into 30 2 times. 2 times 15 is 30. That's nice. We drop the 8 down. Does 15 go into 8? No, it doesn't. 0 times, okay. So we put the decimal, we drop down this, 80. Oh gosh, 50 goes into 80. How many times? Okay, 15 times 4 is 60. 15 times 5 is 75, so it's going to be 5. And then 15 times 5 is 75. And then we subtract. That's going to be 5, that's 70, and we drop down to 0 again. And 15 goes into 53 times, because 3 times 15 is 45. And then look at that, it looks like we have a repeating 3 here. So it says round your answer to the nearest tenth. So here's the tenth, and we need to round it to, the hundredth is 3. 3 doesn't round 5 up, so our answer is equal to 20.5 feet per second. All right, there we go. Okay, let's do another problem here. Let's go with D. Fast sprinter. So sometimes I think if we just practice these and keep practicing, then it just gets easier over time. You start to get like the process and the pattern. So that's what we're gonna do. We have a couple more examples, and so we're just gonna practice them together, okay? So this says a fast sprinter can run 100 yards in approximately 10 seconds. Use dimensional analysis to convert 100 yards to miles, round to the nearest hundredth. And then it says there are 1,760 yards in a mile. So that's kind of like our key, right? This equals 1 mile. So we're going to be using that conversion factor written as a fraction. So it says a fast sprinter can run 100 yards in approximately 10 seconds. So we're going to go here and write 100 yards in 10 seconds. 100 yards in 10 seconds. Okay, so that's where we're starting. And we need to end, where do we need to end? Use dimensional analysis to convert the yards to miles. So we need to go from yards to miles. So we need it in miles, okay? Okay, so we just need to get rid of the yards. I guess the seconds are okay. So we just put that diagonal, right? The yards diagonal, and then what do we know? Do we know a relationship between yards and miles? Yes, we do, it's right here. So yards and miles, miles goes on top. And what do we know? We know that there's 1,760 yards in 1 mile. So then we just, we have 2 fractions, we're multiplying. We're gonna look to cross cancel first. So the one thing I'm gonna see is that these units, these yards cancel out, which is nice. And now I have my miles per second, which is perfect. I think I can do a little simplification here with the 100 divided by 10, because 10, there's a common factor of 10. 10 goes into 10 one time, and 10 goes into 100 10 times. And then what's nice is that I can cross cancel out here because they both end in a 0, which means they both have a factor of 10. 10 goes into 10 one time, and 10 goes into 1,760. You can just take away that 0, and it's 176. And then if we multiply across, we end up with 1 mile equaling 176 seconds. Okay, so a fast sprinter can run 100 yards in approximately 10 seconds. Use dimensional analysis to convert 100 yards to miles. Round to the nearest hundredth. Okay. So now we just need to figure out how many miles per second that is. And to do that, we have to do this division right here. Well, okay. This isn't going to be a very super fun division, but we can do it. Okay. Round to the nearest hundredth. Okay. So it's 1 is being divided by 176. Okay, so does 176 go into 1? No, it doesn't. So I'm going to put a decimal there. Does it go into 10? No, it doesn't. So I'm going to put a 0 there. Does it go into 100? No, it doesn't. So I put a 0 there. So 1,000. Okay. So does 176 go into 1,000? Yes, it does. Okay. How many times? All right. So 176. I almost want to think about 176 is really, really close to 200. So how many times does 200 go into 1,000? Well, it would go in 5 times. So let's see how close we are there. So if I go 176 times 5, I just want to see how close to 1,000 that is. Because it isn't quite 200, but let's see. So 5 times 6 is 30, right? The 0 carry the 3. 5 times 7 is 35 plus 3 is 38. 5 times 1 is 5 plus 3 is 8. So 880, which means it's 120 away from 1,000, which means that's right. So it's going to go in 5 times. And 5 times that, we just figured it out, is 880, right? And we need to borrow, that's going to be 9, that's going to be 10, so it's going to be 2, 1, 120. Okay, great. What does this say? It says round to the nearest hundredth. So this is tenths, this is hundredth, which just means we need to go one more place. And this 5 is actually going to round that up to a 1. So it's 0.01 miles per second. That would be the answer. All right, so yeah. I actually want to see if you can do some of these on your own. I want you to try to do E and F, okay? So where's my friend? Oh, here's my friend, the Pause Dragon, reminding you to pause your device, go ahead and work out E and F, and then when you get done, press play, and then we'll go over them together. All right, I'll see you in a bit. Okay, I'm back. Let's see how you did. It says a cheetah can run at a rate of 60 miles per hour. So that is 60 miles per hour. Okay, in short bursts. What is the speed in feet per minute? Okay, so we need feet per minute. Do we have either of those? No, we don't. Okay, so what do we know? Do we know a relationship between miles and feet? Yes, we do. So we're going to have to put miles there, put it across, and we put the feet on top. And what's the relationship? There's 5,280 feet in 1 mile. Okay? This is great because the miles are going to cancel out, and now we're left in feet, and now we have one of them that we need, which is great. And then the next thing we need to do is convert the hours into minutes. So, do we know a relationship between hours and minutes? Yes, we do. There's 60 minutes in an hour, so we're going to go ahead and use that conversion factor. So we're going to put hours diagonal across and then minutes down here, and then write in what we know. We know that there's 60 minutes in 1 hour, and so the hours cancel out, and then what are we left with? We're left with minutes, which is exactly what we need. Feet per minute. Okay, perfect. So then we're going to look at the numbers, right? We have our units, feet per minute, which is exactly what we need. Do any numbers cancel out? Yeah, they do. The 60 and the 60. 60 goes into 60 one time, 60 goes into 60 one time. Everything else is just 1. And so we would just multiply across and we get 5,280 feet per minute. Huh. Per minute. That is really, really fast. 60 miles per hour in short bursts. That means that they can go, that's basically a mile per minute. That's crazy. That's super duper fast. A mile per minute? Can you imagine that? God, I don't want to be up against a cheetah. I cannot run as fast as a cheetah. That's crazy. Okay, so that's feet per minute. 5,280 feet in a minute. That's how fast a cheetah can run in short bursts. Wow. Okay. So if you got that one right, awesome job. There was already a 1 on the bottom, so we didn't need to do anything extra, so that worked out really, really super nice. Okay, let's do the next one. Let's see how you did on F. Convert 33 feet per second to miles per hour. Okay, so we need miles per hour, okay? And what we are starting with is 33 feet per second. Okay, so we want to change the feet to miles, right? So that's feet's going to go diagonal. The miles is going to go on top. What's the relationship? We know there's 5,280 feet in 1 mile. And then, so those feet are going to cancel out. And then we just need to get to hours. Do we know a relationship between seconds and hours? We do not, but we know there's a relationship between seconds and then minutes and hours. So we're going to go that route. So seconds goes diagonal. We know there's a relationship between seconds and minutes. There are 60 seconds in 1 minute, right? So those seconds are going to cancel out. Oh, wait. We got it to miles. So that's good. We got that. And then what do we need? What do we need? What do we need? We need the minutes to hours. So we're going to have the minutes go diagonal so that they'll cancel each other out, and hours is going to go on the bottom. And what do we know? We know that there's 60 minutes in 1 hour. Okay, great. So let's go ahead and simplify this, okay? We know that both of these, look at the numbers, both of these are divisible by 10, right? So that's going to cancel out there, that's going to cancel out there. We figured out earlier that 6 goes into 528. It was divisible by 2 and it was also divisible by 3. And we figured it out earlier. And so 6 goes into 6 one time and 6 goes into 528 88 times. And then what's kind of cool is I think I can actually, I think 11 goes into both of these. 11 goes into 33 3 times and 11 goes into 88 8 times, right? Yeah. It does. So that's good. And then we can just simplify the 8 and the 60 because they're both even. So we know that 2 goes into both of them. So 2 goes into 8 4 times and 2 goes into 60 30 times. But they're even again, so that means 2 goes into them again. So 2 goes into 4 2 times, 2 goes into 30 15 times, and that's it. Okay, so now I think we have to, oh, did I not cancel out these units here? Oh, minutes and minutes, they cancel out. We're left with hours. Sorry about that. Okay, now we just multiply across. So we have, I don't think we can cancel out any of the numbers. So it's nice that we're dealing with like really super small numbers. We're dealing with 3, besides all the ones, right? We have 3, 15, and 2. So that's a lot nicer than dealing with 33, 60, 60, and 5,280. So that's just from canceling, cross-canceling. So cross-canceling is very, very, it's a powerful skill. It makes really, really big numbers into smaller, workable numbers. So make sure you do it. 3 times, so we're just going to multiply across. 3 times 15 is 45 miles. And then just 2 times 1 over 2 hours, miles per hour. And it's got to be per 1 hour, right? So we got to go 45 divided by 2. I'm just going to go ahead and do that over here. 45 divided by 2. 2 goes into 4 2 times. 2 times 2 is 4. Drop down that 5. 2 goes into 5 2 times. 2 times 2 is 4. There's 1, drop down a 0. There's a decimal there. You drop down the 0. And 2 goes into 10 5 times. So our answer is, whoops, sorry about that, 22.5 miles per hour. Oops. Made it shake again. Okay. All right, perfect. So let's go on to the next one. G. It says the 2004 Tour de France was 3,391 kilometers. 91.1 kilometers. Lance Armstrong won the race in a little over 83.5 hours. That's a long time. Fill in the blanks to find his average speed in meters per hour. Okay, so we need meters per hour. Meters per hour. Okay, so the relationship you need to know between kilometers and meters are that there are 1,000 meters in 1 kilometer. So we're going to be using that conversion factor. So what do we know? Tour de France, 3,391.1 kilometers. And he did it in 83.5 hours. Okay. So we need meters per hour. All right, great. So it's in kilometers per hour, we need meters per hour. Okay, so the first thing we need to do is just get rid of the kilometers, right? So we need to put that on diagonally, and then we put meters on top. And what's the relationship we know? We know that there are 1,000 meters in 1 kilometer, and the kilometers cancel out, and what we're left with is meters per hour, which is exactly what we need. So now we just really need to, you know, we can't really cross cancel anything with the numbers because these are decimals. So we just need to multiply across and just multiply this number by 1,000, which means this decimal place is just going to move over 3 times. So it would move over 1, 2, 3. So that means our number that we're going to be dealing with is 3391 and then 00 over 83.5. And this is in meters per hour. Meters is just an M. Okay, so we need to determine what this is. So we're gonna have to divide this out. Okay, so I don't even know what is this, 300,000. Okay, 339,100 divided by 883.5. And whenever you're dividing by decimals, the first thing you always have to remember is that you can never divide by decimals. So we have to move this over 1 place, which means we have to move this decimal over 1 place. Okay, which means it moves the decimal place. So we're looking at this. 835. Does 835 go into 3? No. Does it go into 33? No. Does it go into 9? Yes. No, it does not. 339, it does not. Does it go into 3,391? Yes, it does. How many times? So sometimes with something like this, I like to just think about 8, and I like to just think about 33. So 8 goes into 33 4 times. So there's a possibility that this might just go 4 times, but I'm not exactly sure. So I'm going to go over here and I'm going to go 835 times 4 and figure out what that is. So that's going to be 20, 12, 14, and 32, 33. And it's 3,340, which is less than that, so that will work. So that means that it goes in 4 times, and it ends up equaling 3,040 like that. Okay, that's nice. Then we subtract, and we get 1, we get 5, and then that's just 0. So then we bring down this 0. And does 835 go into 510? No, it doesn't. So we put a 0 above the 0. And then we take down another 0. And yeah, let's see here. Does 835 go into that? Yes, it does. So I want to think about the 8 and 51. How many times does 8 go into 51? Well, 8 would go into 51 like 6 times, because 6 times 8 is 48. So let's figure out what 835 times 6 is. That would be 6 times 5 is 30. 6 times 3 is 18 plus 3. would be 21, write the 1, carry the 2. 6 times 8 is 48, plus 2 would be 50. And I think that works. So it goes in 6 times. Right, that 0, yep. It's above that 0. And then the answer is 5,000, 0. Okay, which means that's 0. We have to borrow here. That makes that 9, and then the rest of that's 0. So then we have to drop down this 0 here. And does 835 go into 900? Yes, one time. That is nice. 1 times 835, just 835. And then we subtract. What do we get? That's going to be 8. This is going to be a 9. That's going to be a 10. So that ends up being 5 and 6. And then we drop down, make a 0 here, drop it down. Does, and put the decimal up there. Does 835 go into 650? It does not. So that would be a 0 here. And then, yeah, you would add another 0, drop it down. Does 835 go into 6,500? I'm sure it does. Let's see. Does it go in? I'm thinking about 8 and 65. I doubt it goes in, like 8 times 8 is 64. And I don't think it's going to go in that many times. I think it's going to go in 7 times. So let's figure out what 835 times 7 is. 35, 3 times 7 is 21. That would be 24. 56, 58. So 5,845. That's right. Yeah. Okay, so then we subtract. That's, whoa, I don't want to borrow from that one, borrow from this one. Make that a 10, make that a 9. So that's going to be 4, that's going to be 6, that's going to be a 4, borrow 14, 16. Yep, that works. So it goes in, how many times? 7 times. Okay, so at this point, it didn't really say how far we had to go, so I'm just going to round it to the nearest tenth, which means I would go to the 100th, and then that would round this up to a 1. So that means my answer is going to be 4,061.1 meters per hour. Okay, so that's how fast he was going. Perfect. Okay, on to our last one. Hopefully you're getting the hang of this. So it says a soft serve ice cream machine makes 1,200 gallons per hour. Convert this rate to cups per minute. Cups per minute. Okay. So we have 12,000 gallons per hour. And we need to go to cups per minute. So let's go ahead and get rid of the gallons first. Do I know a relationship between gallons and cups? No, I don't, but I know a relationship between gallons and quarts and pints and cups. So we're going to go on a little bit of a journey, a mathematical journey right here. So gallons are going to go on the bottom, right? And quarts are going to go on the top. So what's the conversion factor here? Yes, there's 4 quarts in 1 gallon. Okay, gallons cancel. We got to get to cups, right? So we got to go to pints. So quarts goes diagonal. Pints goes on top. What's the relationship we know? We know that there's 2 pints in 1 quart. Quarts cancel. That's awesome. Now we got to go to cups. So there are pints goes diagonal and cups goes on top. So we know that there are 2 cups in 1 pint. And then the pints go, and finally we are at cups. Okay, so we have that one, but now we have to go to the minutes. So, got to get rid of the hours. Do we know a relationship between hours and minutes? We do. That one's kind of nice. And it's just, what is it? What is it? It's hours goes up here, right? And what goes down here? Hours and minutes. So minutes goes down here. What's the relationship? There is 60 minutes in 1 hour. Perfect. Okay, well, there we go. So, yeah, that's it. What happens? The hours cancel out, and then we're at minutes. So we have our cups per minute, which is great. Now we just need to simplify all this stuff. So I think the first thing I see is that both of these have a 0 on the end. That means they're both divisible by 10. So I'm just going to take off that 0 and take off that 0 right there. Okay, that's nice. Then what I'm going to do, what do I know? I know that I can cancel out here with one of these 2's because, you know, they both have a common factor of 2. 2 goes into 2 one time. 2 goes into 6. How many times? How many times does 2 go into 6? 3 times. And then the last thing I could see is maybe is 3 go into 120? Because it doesn't go into 2 and 4. If I add up the digits, right, to see if something's divisible, 1 plus 2 is 3, 3 plus 0 is just 3, and 3 is divisible by 3, so that means 120 is divisible by 3. So if I go right here, go 120 divisible by 3, 3 goes into 12, 4 times 3 is 12, 0, drop it down, and it's basically 40. So 3 goes into 3 one time, 3 goes into 120 40 times, right? So basically the numbers that are left is just have nothing but ones on the bottom, and I have 40 times 4 times 2 on top, which is super nice because basically, you know, if I think of 4 times 2 times 8, all I got to do is go 40 times 8, and I have the answer. 8 times 0 is 0. 8 times 4 is 32. So I end up with 320 cups per minute. And there we have it. So that's our answer. So I hope you understand this stuff. If you have any questions about this, please ask them in our next class. Otherwise, I will see you in a little bit for example 4.